Hi guys, I'm Richard and today I'm looking at the Core i3-6100. That's the new Intel dual-core quad-thread processor based on the new Skylake architecture. Okay, so what's the big deal about Skylake? Well, it's basically Intel's latest iteration of its core architecture, much faster than anything that we've seen previously. And going into this, the thing that intrigued me was the possibility that maybe we could actually overclock a non-overclockable part. So let me explain. When you overclock a CPU, there are two elements that are in play. First of all, there's the base clock, typically that's 100 megahertz, and secondly there's the multiplier, and on this part it's set to 37. So 37 times 100, the base clock, gives you 3.7 gigahertz. Usually on Intel's overclockable parts, the multiplier can be adjusted, but they can't be on the non-overclockable parts. And the good thing about Skylake is that you can actually tweak the base clock. So we were kind of hoping that with the locked Skylake CPUs we would still be able to overclock them, maybe just by upping the base clock by around 10%. That would get us over 4 gigahertz. So a dual core part, 4 threads, 4 gigahertz, that would be really good for gaming. So before we go on, let's talk about our core components. Motherboard wise, here we've got MSI's Z170A Gaming M5, and it's backed up by two 8GB sticks of Corsair 2666 MHz RAM. Now both of those components are actually really crucial to this testing. And we're using the standard Intel heatsink and fan here, and the reason why is that on a budget build, every pound counts. So we started benchmarking this board with the memory modules running at the full 2666 MHz. But as we were testing, MSI came back to us and said, look, the lower end boards in this series, they only run the memory at 2133 MHz. But you know, we didn't really think too much about it. After all, pretty much every test that's been done in the past has demonstrated that faster memory makes no impact to gaming performance whatsoever. But we wanted to test just to make sure. Okay, so how do we benchmark a CPU in gaming scenarios? Well, what we do is we pair it with the most powerful single-chip GPU on the planet, and at the moment that's NVIDIA's Titan X. So we operate gameplay at 1080p, we run on the Titan X at max settings. So let's consider the role of the CPU in gaming. Its job is to basically process all of the game logic, and it's also there to prepare all of the calls for the GPU. So what we do is we run all of our games at 1080p, and we run them at max settings. Basically, the more there is to draw, the more the CPU is going to be stressed. So in these benchmarks, you're seeing how the i3 compares to our previous Skylake benchmarks on the i5 and the i7. And you can see that there's quite a gap between them, obviously. But what's more noticeable here is that the i3 actually produces two very different performance profiles when we're running with the faster RAM and when we've got it paired back to 2133 MHz. And some of the results here are actually very significant. With The Witcher 3, we see an 11.6% performance boost. Assassin's Creed Unity, 7%. Far Cry 4, 11%. And with Rise, there's a colossal 76.4% increase. And basically what that's telling us is that for some games, memory speed really does make a difference. And this goes against the accepted wisdom. Okay, so our tests are artificially pushing the CPU to the forefront here. It's very unlikely that you're going to be combining a Titan X with a low-end CPU like the i3-6100. So typically you'd expect the GPU to be the major bottleneck during gameplay, and for a lot of games that is often the case. But it's safe to say that gaming is requiring more powerful CPUs year on year, and on top of that, a dual-core part is more likely to hit CPU limits than a quad. So the question is, are our benchmarks realistic? Now, we're pairing the Titan X with an i3 here, and it's safe to say that that's a pretty unrealistic pairing of components. We're talking about a sub £100 CPU with a £1,000 GPU. It's frankly insane. But it's safe to say that the CPU requirement on top-tier games is increasing every year, and you're more likely to hit a CPU bottleneck with a dual-core i3. And in that scenario, faster RAM will definitely make a difference. And to illustrate, take a look at this. Here we're looking at Crysis 3 running at high settings. That's actually one notch down from the max, and it's paired with an inexpensive GTX 950. That's a £130 graphics card, far more realistic to be paired with the i3. But you can see here that there's definitely a difference running with faster memory here, and that's because we're CPU bound. And all of that led us to wonder, what about the last gen Core i3, and what about AMD's FX 6300? They were really good budget CPUs, but maybe faster RAM would help them too. So we decided to re-bench our old Core i3-4130 and see what happened there. Now, we used a Z97 motherboard, which allows for overclockable memory, and yet we found the same differences again. So take a look at this. We're using the Core i3 4130 with the standard 1600 MHz memory that you're allowed to use on the lower end boards, and the 2133 MHz memory you can use on the higher end boards like the Z97 chipset. And you can see that we actually see an uplift again. The Witcher, it's about 7.4%. Crysis, it actually zooms up to 16.8. And Ryse, which crippled the Skylake chip with slower RAM, actually sees a 66% uplift, so clearly it helps there. As for the AMD FX 6300, unfortunately our motherboard wouldn't let us run faster RAM. Okay, so we came into these tests hoping that we could actually overclock the Core i3 itself, and the bad news is that, well, basically you can't. We managed a mere 2% uplift using the base clock, an extra 77 MHz, which isn't really going to be a game changer. But what surprised us is that there is actually an overclocking route available. It's just not the one we were expecting. Faster memory in CPU-bound situations definitely helps. So there's a couple of pieces of established wisdom that we've managed to challenge here. First of all, there's the notion that running a Core i3 or a similarly locked chip on a cheaper motherboard offers all of the performance of a more expensive board. And that simply isn't the case. The more expensive boards do allow the option of faster memory, and faster memory in CPU-bound scenarios means higher performance. And secondly, there's the whole status of RAM in any given gaming PC setup. It's fair to say that there is a hierarchy of performance bottlenecks. At the top you have the GPU, and after that the CPU. But what our tests have demonstrated is that faster RAM is just as important there in getting the most out of your CPU. So in building a budget gaming PC, we do recommend faster memory, and we also recommend taking a look at a slightly more expensive board that can run it. Okay, so during this video we haven't really concentrated that much on the base performance of the Core i3 6100 itself, but suffice to say that compared to our last gen Haswell chip and the FX 6300, it's clearly a step ahead, and it's the best sub-100 gaming CPU that money can buy at the moment. Okay guys, so that's all we've got for now. If you want to see the benchmarking runs in their entirety, you'll see them elsewhere on the channel. But in the meantime, give us a like if you enjoyed the video, and subscribe if you want to see more PC and console tech analysis.